Hey there everyone, Ramesh here. Welcome to Spring Data REST tutorial. So in this tutorial we are going to see the beauty of Spring Data REST module and why Spring team introduced Spring Data REST module. Alright, so basically Spring Data REST is built on top of Spring Data repositories, and basically this module will scan all the entities or models in our application, and it will create a REST endpoints automatically for our model or entities in our application. We don't have to write a REST API code for our entity or model in our project. Spring Data REST module automatically create REST endpoints. Alright, so we can use Spring Data REST module to minimize the code uh, for writing REST APIs. So we'll learn a lot about Spring Data REST in this tutorial. So before deep dive into Spring Data REST, let's first understand what is the problem Spring Data REST module solves. Okay, so in typical Spring MVC project, we typically create a controller layer, service layer, and a DAO layer, right? And in controller layer, let's say if we want to create a REST endpoints for employee, then we need to create an employee controller, and then we develop a REST endpoints for employee. Okay, and similarly in service layer, we first create an interface, employee service, and then we create a class employee service IMPL, which implements employee service interface and implements all its methods. Okay, so for single entity, let's say employee, we need to create 3 files. Okay, and let's say if we want to create a REST APIs for other entities like department, project, company, users, etc., then we need to create a controller, service interface, service class for each of these entities. Alright, so if you can observe the code, only the entity name is changing over here and rest of the code remains same. Okay, so we are basically repeating the same code again and again. Alright, so we can think the solution for this problem. The solution can be automatically creating a REST APIs for a entity. Okay, we are only changing the entity name here, but if you can see, the code remains same. Okay, so that is the problem that Spring Data REST solves. Okay, so Spring Data REST module is a solution for this problem. So basically Spring Data REST uses interfaces which extends JPay repository, and Spring Data REST creates a crude REST APIs for entity for free. Okay, so basically Spring Data REST helps to minimize the boilerplate code required for controller layer. Alright, so I hope you understood how Spring Data REST solves the problem. Okay, so we have a controller, service interface, service implementation class. So each and every entity we need to create these files, 3 files, right? So Spring Data REST basically automatically create a REST endpoints for entity. We no need to write a REST APIs. Okay, that is the beauty of Spring Data REST. So when we create a Spring Boot application using Spring Data REST, we will see how we can minimize this code. Okay, let's take a look into what are the REST endpoints Spring Data REST module exposes. Let's say we have a user resource or user entity in our project, then Spring Data REST module will basically exposes all these REST endpoints. Get all users, get user by ID, create new user, update existing user, delete user, pagination, and sorting APIs. Okay, so we don't have to write a REST endpoints for user entity. Spring Data REST module expose all these REST endpoints for us as a free. Okay, and let's say if there are multiple resources or models or domain entities in our project, then Spring Data REST module will expose us REST endpoints for all the models or entities or resources in our project. We don't have to write a boilerplate code again and again. That is the beauty of Spring Data REST. Okay, now you might be wondering how Spring Data REST works. Well, basically Spring Data REST scans JPay repositories in your project. Okay, for example, let's say you have user repository or employee repository, right? So these repositories extends JPay repository. So Spring Data REST module scan all these repositories, and based on the entity type that we pass to JPay repositories, it will create a REST APIs. For example, look at here, we have an employee repository, it extends a JPay repository, and we pass employee entity as argument to the JPay repository. And JPay repository basically exposes crude methods to perform a database operation on employee entity, right? And Spring Data REST module basically scan JPA repositories. Okay, so basically the repositories which extends a JPA repositories, and based on the entity type, it will create a REST APIs for employee entity. So similarly, let's say one more example, user. Okay, when we create a user repository which extends JPA repository, and we pass user entity as argument to the JPA repository, right? So Spring Data REST module basically scan user repository, and based on the entity type, that is user, it will create a REST APIs. Okay, so this is how Spring Data REST works. So it don't create controller or service a layer. So it will basically scan these repositories, and based on the entity type, it will create a REST APIs for entity. Okay, great. Now let's see how Spring Data REST creates a REST endpoints. So by default, Spring Data REST create a REST APIs based on the entity type, like employee, user, student, project. For example, look at here, user repository extends JPay repository, and we pass user as an entity, right? So by default, Spring Data REST creates REST APIs based on the entity type. Okay, and how the REST API URL that Spring Data REST creates. So it's simple. It uses simple pluralized form. So first character of the entity is lowercase, and then it adds s to the entity, end of the entity. For example, let's say we have a user entity, and Spring Data REST will basically create a REST point URL like this /users, and the first character of the entity is lowercase. So this is the first character, u is in capital, right? And Spring Data REST will just lowercase the first character like small u, and then it will append s at the end of the entity. Okay, this is the pluralized form. Similarly, one more example is employee. So it will lowercase the first character, and then it will add s at the end. Similarly, for student, it will first character of the entity is in lowercase, and then it will add s. So this is basically looks like a pluralized form. Okay, so Spring Data REST will exposes REST APIs based on the entity type, and it will internally use a pluralized form, and the first character of the entity is in lowercase, and then it will append es to just make the entity into pluralized form. Okay, so this is how Spring Data REST creates the REST endpoints. Next, let's see heteros. So Spring Data REST APIs are heteros compliant. The response of all the REST APIs that are generated by Spring Data REST module are in heteros format. So basically the response contains a metadata links to other data or REST APIs. Alright, so basically you can expect the response of the REST APIs that is generated by Spring Data REST module are in heteros format, and you can see in a heteros format we will see a lot of links that will navigate to the other REST endpoints. We will see more about heteros in project development. So now let's take a look into Spring Data REST application architecture. So before we were creating a controller, service, DAO layer, right? So this is 3-layer architecture. Now in case of Spring Data REST application architecture, we don't have to create a controller layer, okay, and we don't have to create a service layer. Alright, so this is how Spring Data REST minimizes the boilerplate code that is required to develop a controller layer and service layer. So Spring Data REST module basically uses Spring Data JPay repositories, and based on the entity type that we pass, it will create a REST APIs for that entity. Okay, so look at here how the architecture is simplified by Spring Data REST. Okay, great. Now let's take a look into the development steps. So we first create a Spring Boot application. using Spring Initializer, and then we'll import in IntelliJ IDEA, and we are going to add Spring Data REST dependency, and we create a JP entity, and then we create Spring Data JP repositories for JP entity, and that's it. We no need to create a controller layer, we no need to create a service layer. Spring Data REST module will expose REST APIs for entity in our project. We don't have to write a service layer, we don't have to write a controller layer. Okay, that is the beauty of Spring Data REST. Okay, so let's go ahead and let's create a Spring Boot application using Spring Initializer, and let's import in IntelliJ IDEA, and let's see how Spring Data REST exposes REST endpoints. So let's head over to the browser over here and just type start.spring.io. This will navigate to Spring Initializer website. So Spring Initializer is the standard way to create Spring Boot application, right? So here we have two kinds of project types, Maven project and Gradle. We are going to use Maven. So let's keep Maven project as selected over here, and language Java, and Spring Boot version 2.5.2. so this is the latest and stable version, so let's keep selected as it is. Don't use snapshot because they are not stable. And project metadata, so we are going to provide a metadata for the project here. Group as net.javaguides, and artifact as Spring Boot Spring Data REST tutorial, something like this, and name of the project is same as artifact, and description, let's say demo project for Spring Boot and Spring Data REST. Next, package name net.javaguides.spring data REST. Okay, and packaging, choose Java, and here we are going to use Java 16 or Java 11, Java 8. So you can choose any Java language or any Java version that you have installed in your machine. So I'm going to use Java 16, which is the latest of Java as of now. And in a dependency section, we are going to choose the dependencies. So let's go ahead and let's choose Spring Data REST dependency. Okay, REST repositories, and then we are going to use Spring Data JP dependency. Alright, and then we use Lombok dependency. Okay, and then we use S2 database. So to keep it simple, we are going to use S2 database, but if you want to use MySQL database or PostgreSQL database, then you need to choose the JDBC driver for respective relational databases. Okay, so again I'm going to use one more dependency, that is Spring Boot DevTools dependency. So let's review our dependencies: REST repositories, Spring Data JP repository dependency, Lombok dependency, S2 database dependency, Spring Boot DevTools dependency. Alright, and you can explore about your project details over here by using this button, explore, and you can see the pom.xml and what are the dependencies the pom.xml contains. So we have Spring Boot starter data JP dependency, Spring Boot starter data REST dependency, and then DevTools dependency, S2 database dependency, Lombok dependency, and we have Spring Boot Maven plugin. And you can go to source folder and you can explore the project structure over here, and we have application.properties file. Okay, so this is the standard project structure that Spring Initializer will basically create. Then close it, and we are going to generate this Spring Boot application as a zip file. So go ahead and click on generate over here. So this will download Spring Boot application as a zip file on our file system. Alright, so go ahead and open this zip file in a folder and go ahead and extract this folder. Okay, now let's open IntelliJ IDEA and import this project in IntelliJ IDEA. So I have opened IntelliJ IDEA over here, and I'm going to import the existing project. So go ahead and click on open over here, and my project in downloads folder. So I'm going to choose Spring Data REST tutorial project from downloads folder over here and click on OK. So once our Spring Boot application is imported successfully in IntelliJ IDEA, let's go and let's create a JP entity. Okay, go to the SRC folder and main folder. Within the main folder we have a Java package. Within the Java package we have net.java.spring data rest base package. Right click on base package, okay, new, and then choose package, and let's give package name as entity. Hit enter, and again let's create one more package. Right click on the base package, new, and then choose package. Let's create package name as a repository. Alright, now go to entity package, right click on entity package, new, and then choose Java class. Let's give class name as user. Now let's go and let's create few properties or fields in user entity. Private long ID, private string first name, private string last name. Similarly, let's create one more field, private string email. So to keep it simple, I'm going to create only these 4 fields in user entity. So now what we're going to do is we're going to use Lombok annotations. For example, we're going to use add data Lombok annotation to automatically generate getter setters and toString hash code equals methods. And also I'm going to use here add all argument constructor. Also I'm going to use add no argument constructor. Alright, now we have a simple Java class. Let's make this Java class into a JP entity by using JP annotations. Let's use add entity annotation. So make sure that you choose entity annotation from javax.firstLessons package. And now we also need to provide a table name for this entity. Okay, so for that we're going to use add table annotation, and add table annotation has property or attribute that is name, and we can give a name as users, and we need to define the primary key, right? So for that we're going to use add id annotation over here, and we need to also specify the generated strategy, primary key generation strategy over here by using add generated value annotation. And we're going to use a generation type as identity, and here we're going to use add column annotation to provide or map a column name for these fields. We have a name attribute, and let's give column name as first underscore name, and we have a few more attributes like null label equal to false, so this attribute will make this column as a not null. So similarly, let's use add column annotation for last name as well. Name equals to last underscore name, and similarly for email. So the column name for email looks good. We don't have to use add column annotation to provide a column name for the email field. Let's save the file. So if you don't provide add column annotation, then Spring Data JPA is smart enough to provide a default column name as a field name, and if you don't provide a add table annotation, then JPA is smart enough to provide a default name for the table as a class name. Okay, great. Now save the file, and we are going to create a repository now. So go to repository package, right click on it, new, and then choose Java class and choose interface, and let's give repository name as user repository. Hit enter, and this repository should extends JPA repository interface. And look at here, JPA repository interface takes 2 arguments. Okay, first is type of the entity and second is type of the ID. So go ahead and give the type of the entity as user, and second the type of the primary key, that is long. Okay, great. Now we have generated Spring Data JPA repositories. So Spring Data REST module will basically scan JPA repositories in our project, and based on the entity type that we pass, it will create a REST endpoints for entity. So now Spring Data REST will create a REST endpoints for user entity. Let's say if we create a few more entities in our project, then Spring Data REST module will generate a crude REST endpoints for each and every entity in our project. So one more important point here is we don't have to add repository annotation over here, because JPA repository has an implementation class, that is simple JPA repository implementation class, which will already annotated with add repository annotation, so we don't have to add repository annotation over here. Okay, so Spring Data JPA will internally take care of it. Now we have created a JPA entity and a repository for JPA entity, that is user. Now what we're gonna do is we're gonna insert few records in users table. Okay, for that we are going to write a code snippet here. So we are going to implement command line runner interface, and we're gonna quickly write the code to save some records in a users table. So here I am going to auto-wire user repository, because user repository exposes crude methods to perform database operation on user entity, right? So for that we need here user repository. Go to user entity and we are going to use add builder annotation. So go ahead and here just provide add builder Lombok annotation. So this will basically create a builder pattern for user entity. Okay, so this is a very useful annotation we can use to create object using builder pattern. So go to Spring Data REST tutorial application class over here, and within a run method we are going to create object of user. Now user equals to, we are going to use builder pattern here to create object of user dot builder, and then dot first name, let's say Ramesh, last name, let's say Fartare, and then email, let's say ramesh@gmail.com, and finally we will call build method. So this will build a user object. Okay, and then we're going to use user repository provided save method to save the user object into a database. Perfect. So we have saved one user. Now similarly, let me copy this and let's create a few more users and save to the database. Let's call it as user 1. Okay, and let's say John Sina as a second user, and email as sina@gmail.com, and this, let's call it a user 2, and this should be a separate user, like let's say Tony Stark, and email can be tony@gmail.com. Okay, and just pass user 2 here, and this one user 1. Okay, now we have created 3 users and we have saved 3 users in our database. So similarly, let's create a few more users. User 3, and first name let's say Sanjay, second name let's say Jadhav, sanjay@gmail.com, and this is should be user 3. So let me copy paste here one more user 4, and let's say Amir as a post name and last name as a Khan, and email ID something like amir@gmail.com and user 4. Alright, now we have created 5 users and saved in a database. Alright, so as we are using S2 database as a embedded database, so these records will be saved when we start our Spring Boot application. That's it. We have created user JP entity and then we have created user repository. We don't have to write a controller layer to write the REST endpoints. Spring Data REST module will take care of creating a REST endpoints for us. So basically Spring Data REST will scan user repository and its entity type, and it will create a crude REST endpoints for user entity. That's it guys. We don't have to write service layer, or we don't have to write a controller layer over here. So that is the beauty of Spring Data REST. It minimizes a lot of code, right? Great. Now what we're going to do is we're going to run our Spring Boot application. Let's explore how Spring Data REST create and exposes REST endpoints. So I'm going to run Spring Boot application here. And we're going to use Postman REST client to test the REST endpoint. So make sure that you have a Postman client in a place. Let's head over to the Postman client, and from the Postman client we're going to call the REST endpoints. So here we need to enter the URL. Let's say localhost .8080/users. Okay, so by default this is the URL 8080/users, and users basically is the pluralized form of user entity, right? So Spring Data REST module will basically expose REST endpoints by using this URL. Now go ahead and click on send button, and there we go, we got a response. Okay, so if you can closely observe the response over here, underscore embedded, and within that we have array of users. And look at here, so Spring Data REST module uses heteros format. Okay, so underscore links, and then it will provide a links for other REST endpoints. So we can use this link to get a user with ID 2, and you can get a user with ID 3. So this is how Spring Data REST module exposes REST endpoints with a response in a heteros format. Okay, so within underscore embedded object we have array of users, and then within each user object we have a user with a metadata. So this is the heteros format, and this is called a metadata for other REST endpoints. Okay, so response looks good, right? And apart from that, you can see here, whenever we call get all users REST API, it will also provide a pagination. Okay, size, total elements, total pages, number. Alright, we don't have to write paging and sorting REST APIs. So Spring Data REST will expose us paging and sorting support for this REST API. Okay, now what we're going to do is we're going to call get user by ID REST API. Okay, and look at here, we are going to pass user ID 1 here, and go ahead and click on send button, and there we go, we got a user with ID 1 in a response. And again, this is the response in a heteros format, and this is the metadata for other REST APIs. Alright, so apart from this, we're going to use post to create a user. So just remove this one here and go to body, and in a response I'm going to copy these 3 fields from the JSON object and go to raw here. Okay, and make sure that you choose a content type as JSON over here, and in a body I am going to create a JSON object, and let's give different name here. First name as a Ram and last name as Jadhav, and ram@gmail.com, and go ahead and click on send button, and look at here, the user is successfully saved in a database, and we got a response of the REST API in a heteros format. And you can test this REST API by just passing the ID. So look at here, the ID is 6 now. So go ahead and pass the 6 here and choose get method and hit send button, and there we go, got a user with ID 6. So similarly we're gonna test update REST API. So here we need to pass the ID of the user that we are going to update. So I'm going to update user 6, and here I'm going to update first name. Let's go ahead and let's give first name as something like Viraj, and I'm going to update last name something like Viraj, let's say Pawar, and email something like viraj@gmail.com, and go ahead and click on send button, and there we go, the response. Okay, first name, last name, email is successfully updated. Alright, and if you can call get method with user ID 6, you can able to get a same response. Okay, the updated user, first name, last name, and email. So similarly, let's go ahead and let's test the delete REST API. So I'm going to choose delete HTTP method over here, and I'm going to delete a user with ID 6. So go ahead and click on send here, send button, and there we go. So user successfully deleted, and we got a status 204, no content as a status code. So if you try to get this deleted object, then you will get an error response, that is 404 not found status. Okay, great. So we have tested all the crude methods. Now if you can see the URL over here, localhost:8080/users. So this not looks good, right? We need to add a base path here, something like, let's say API or v1, okay, something like that, or you can use any base path here. For example, you can say REST API, something like this. We need to provide a base path for these URLs. Okay, so in order to do that, we can use a property, that is Spring Data REST base path property, to provide a base path over here. So let's see how to do it. So go to IntelliJ IDEA again and go to application.properties file, and here just type the property spring.data.rest.base-path equals to, here I'm going to provide a base path as API/v1/, okay. So this is going to be a base path for my all the REST endpoints for user entity. So go ahead and restart the application, and let's see how this works now. Alright, our Spring Boot application is up and running. Let's head over to the Postman client, and let's give a base path over here /API/v1, and go ahead and click on send button here, and there we go, we got a success response. It means that we have successfully configured a base path for all the REST APIs for user resource. Similarly, I'm going to test get user by ID REST API here. So I'm going to fetch a user with ID 1, and there we go, we got a success response in a heteros format. So similarly, I'm going to test the post REST API. So let me copy this JSON object, and here I'm going to choose post and remove this /1 here, and go to body, go to raw, and paste object in a body here, and make sure that you choose a content type as JSON, and go ahead and click on set button, and there we go, user is successfully inserted. Similarly, I can test the update REST API. So here we can update a user with ID 6, and here I'm going to update first name, let's say something like Sanju Pawar, and sanju@gmail.com, hit send button, and there we go, first name, last name, email is successfully updated. Similarly, I am going to test the delete now. So choose the delete HTTP method over here and click on send button, and there we go, User with id 6 is successfully deleted, and we got a status 204 no content. Alright, it means that we have successfully configured a base path, that is API/v1. Now if you can see that sometime the requirement is something like we don't want this REST API URL /users. We sometime want some different name here. So Spring Data REST provides the flexibility to configure the REST API URL. Spring Data REST module provides an annotation called add repository REST resource annotation that we can use to configure the REST endpoint name here. So we have users, we can replace from users to members, something like this. Okay, let's see how to do it. So go to IntelliJ IDEA again, go to repository, user repository, and here we use the annotation add repository REST resource, and here we can provide the path, let's say members. Okay, so this is the annotation which is very useful whenever you want different name for the REST endpoints for a given entity. Then you can use this annotation and provide the path for the REST APIs. Alright, so go ahead and restart the application and let's see how this works. Our Spring Boot application is up and running. Let's head over to the Postman client. Alright, and here for example I'm going to test get method. Okay, so look at here, I have just replaced from user to members, right? And I'm going to send the request, and here, there we go, we got a successful response. It means that we have successfully changed the REST endpoint path URL, that is from users to members. Similarly, we can test get user by id REST API here. Okay, great. Similarly, we can test post REST API here. So we have already a body with an object, so we can save this object. Okay, so look at here the response. We can similarly test the delete. We are going to delete first user with id 1 and hit send button, and there we go, user deleted successfully. It means that we can configure the path as per our requirement by using add a repository REST resource annotation. So very useful, right? Now let's explore how Spring Data REST module supports pagination and sorting. Okay, by default Spring Data REST module provides pagination and sorting support, but we can customize pagination and sorting. For example, look at here, I'm calling get all users REST API, and we got a response in a heteros format, and you can just go down and you can see page object. So the page object contains all the pagination information like page size, total elements, total pages, number, etc. And by default the page size is 20, but we can customize the page size as per our requirement. So instead of 20 we can give 5, 10 as per our requirement. And total elements in a table we have 5 records, and based on the page size the total pages is 1. Okay, and we can use the query parameters to to get a response. For example, I can give a query parameter page equals to 1. I want page 1, and the total elements I want to show in a page 1, that is size equal to 3. So in this case we will get 2 pages. In first page we will see 3, and in second page we will see 2. Okay, because we have total 5 elements and the size is 3. So once we hit the request we'll get a response, and let's see the response here. So look at here, size we have specified 3, and total elements we have 5 records in a table, and total pages now we'll get a 2. So in first page we will see 3 elements, in a second page we will see 2 elements. Okay, so this is how we can customize, we can call the REST API with page and size as a query parameters. And if you can go up here, you can see links. You can go to the respective pages by using these links. If you want to go to page 0 with size 3, so just remember page starts from 0 index, so you can customize that in your code. So sometimes the UI sends a page 1, right? But Spring Data JP internal uses page size as an index 0. Okay, starting index 0. Now if you just look at here, page 0th page means page in page 1 with size 3, we can call this API. And if you want page 1 with size 3, you can call this REST API. I'm going to call this REST API now, and you can able to see when I send the request, you will see only 2 elements, I mean 2 objects in a response, because in a first page we see 3 elements, in a second page we will see 2 elements, I mean 2 objects. Okay, so this is how we can call the API with page and size. And by default, if you remove page and size here, and if you call the REST API, by default page size is 20, but you can customize this page size. So let me show you how to customize it. So go to application.properties file here, and here we can override the property called Spring Data REST dot default page hyphen size. Okay, so here we can specify, let's say I will specify 4 here, and let me quickly restart the application. Okay, the application is up and running. Let's head over to Postman client and again call this REST API, and we got a response. Go at the bottom, you can see size 4. Earlier we saw that the page size is by default 20, right? Now we have customized the property in application.properties file as a default page size 4, so the page size is reflected in a response. Now based on the page size, we will get a total elements, I mean we will get a total pages here 2, right? This is how we customize the pagination size. Okay, and in terms of sorting, we can provide a query parameter to sort the elements. For example, here we can provide a sort equal to first name. If you want to sort the users by first name, then you can just provide this query parameter sort equal to first name. So this will sort users, list of users by first name. Go ahead and send request, and you can able to see here by default it will sort in this in a ascending order, and you can see Amir AF comes first, and then J John, and then Ramesh or Sanjay. Yes, okay, great. And if you want to sort users with last name in ascending order, then you can just specify the last name here. Okay, great. Okay, John, Sina, and then Fatare, and then Khan, okay, and then Jadab. So if you want to sort by email, you can just specify email here. Okay, so this is how the Spring Data REST supports for sorting. And if you want to sort the list in descending order, for that we can specify like this: sort equal to first name, comma, and then descending. Okay, so this will sort a list of users in a descending order by its first name. Let me test that one. Yeah, here you can see first name T comes first, because we are sorting a list of users by first name in a descending order. T comes first, and then Sanjay, and then Ramesh, okay, and then John. Alright guys, this is how we perform pagination and sorting support for the REST API using Spring Data REST. We don't have written any code in terms of pagination and sorting support. Spring Data REST module has provided automatically provided pagination and sorting support for list users REST API. Alright guys, so this is the beauty of Spring Data REST. We don't have to write any code. Spring Data REST module provides pagination and sorting support for the REST APIs. Okay, great. Now let's see how to write query methods in Spring Data JP repositories and how to get a response of query methods using Spring Data REST module. So go to user repository, and here I'm going to write one custom query method here. Let's say list of users. Okay, and let's give a standard format for creating query method, something like find by first name. So I'm going to find list of users by first name here, and here I'm going to provide a param. So param is for handling query parameter in a request, and here I'm going to provide query parameter as first name and then string first name. Pretty simple. Okay, so we use this post name in a query parameter in a request URL that we will see a bit later. Okay, now we'll see how Spring Data REST exposes this as a REST API. Okay, so basically Spring Data REST module exposes this REST API as a search API, and we can use this find by first name as a query parameter. Okay, and this first name as a query parameter value. So let's see how to test this REST API. So let me run Spring Boot application quickly. Okay, our Spring Boot application is up and running. Let's head over to Postman client. Okay, and here what I'm doing is I'm gonna call search here. Okay, after search we have find by first name. Okay, and then we have a query parameter first name equal to Ramesh. So this will give you a result like find list of users by first name. Okay, so go ahead and hit send button, and there we go. We got a response, and in a response you can see only the user with the first name Ramesh. Search and then followed by query parameter name and followed by query parameter first name. So this first name query parameter we have configured using add param annotation here. If you can specify the query parameter name as per your requirement, instead of first name you can say yep name. Okay, and whatever the query parameter name you have given here you should give in a request as well, and Ramesh is the query parameter value. And if you want to find by last name, then you can do similarly, you can do like this. Okay, similar to find by first name, you can just write find by last name or find by email, and you can test by using Postman client. Okay, similar to this one, find by first name. So this is how we write a custom query parameter, and a Spring Data REST module exposes this as a REST endpoint, and we can test this REST endpoint by using this format. Okay, and you can also use add query annotation to write the JPQL queries. Okay, similar to this. Alright guys, I hope you pretty much got an idea how Spring Data REST module works and how it exposes core REST APIs with pagination and sorting support. Also we have seen how to create a query method and how Spring Data REST exposes it as a REST API, and we have seen how to test the same. Alright, we have learned a lot about Spring Data REST in this tutorial. Alright, so let me know if you have any question about Spring Data REST in the comment section. I hope you guys found this course useful. Thanks for watching this course. I will see you in the next video.